All right, good morning. My name's Tom Brown, and we're going to talk about beautiful payments with OAuth today. And I am a big believer in the law of 2 feet. So the first thing I wanted to take care of is a quick overview of what we'll be talking today. And if you see that it doesn't kind of fit what you were anticipating, then use the law of 2 feet and check out the other room. So what's on the agenda is, first, we're actually going to do a real quick OAuth demo, because I kind of polled the room and asked if they'd just like to see a popular instance of using OAuth, just to make sure we understand what it does. And then we'll go with the normal agenda. I'm going to talk about the motivation for this talk. A lot of it was a chapter I read in the book Beautiful Security. Then we're going to do the Douala OAuth API, which is just a new payment API using OAuth, which I think is really neat. And then we're going to talk about the OpenTransact mailing list and the activity that's going on there, and why I think it's a good thing. And then we're going to see an example, or actually a few, but we'll actually go through an example with a OAuth consumer called OAuth.jp Karma. And then we're going to actually see a cool thing that Yehuda Katz built called Artifice, which lets us really build APIs, server APIs with OAuth really conveniently. And then finally, we'll talk about kind of future projects that are in the works, and those are currency exchange and federation. Okay, so before we start with the motivation, I wanted to do a simple OAuth example, just so we all know what OAuth is. OAuth is an authorization protocol that emerged in 2007 by some of the open web people, including Kellen Elliott McRae, who's the CTO at Etsy, Chris Messina, and some of those guys. And then was a real, just super grassroots community effort. They took it to spec in April 2009. They had a big security issue, a session fixation attack that the community quickly responded to, and showed real maturity about how we can in a decentralized way maintain very vital protocols on the internet. And now it's being used in payment systems, and so we're really evolving, and right now we're evolving really quickly. So as a kind of a simple example, a really cool consumer of the Twitter OAuth API is a conference manager called Lanyard, and you may have seen it with Lone Star RubyConf. So one thing Twitter allows you to do is actually use OAuth to sign in. So Lanyard, instead of having their own proprietary user accounts, they use Twitter. I think they also use another one of those social networking sites. So what happens is they call it the valet key for the web, OAuth. So what this Lanyard consumer site wants to do, it wants to do actions on behalf of you, the user. And to do that, you have to authorize to let that person delegate those actions. So what happens is they redirect you to the OAuth API provider, which in this case is Twitter. And the way they do that is they use a request token to bind the series of activities that happen during this authorization process to make sure that it's you doing all the steps. And the steps are that you ask, or the consumer asks if you want to, want this service, and it redirects you to the API provider, and there's a request token, and you authorize it under the session of the API provider, in this case Twitter, and then it redirects you back to Lanyard in this case, and Lanyard exchanges the request token for what's called an access token, and so now Lanyard has an access token that it can do the series of actions that you authorize it to do. And there's things in OAuth called scopes, which are now started to be really implemented a lot, which they weren't in the past. And this lets you do granular authorizations of certain actions. So you may have one scope for read, you may have another scope for write, and the idea is you can choose in a granular way which authorizations you want to give to the consumer, and in this case, Lanyard. So Lanyard's asking for to be able just to read tweets and update my profile and post tweets. So that's quite a bit of authorization, but I guess I'll go ahead and let them have it. Dun, dun, dun. And voila, I'm back at Lanyard, and then Lanyard has exchanged the request token for an access token and fetched my contacts, and now there's all this value added that Twitter is giving to it for this conferencing schedule, because now I can see what conferences my Twitter contacts are going to, and that's really cool. And Twitter's really remarkable that it exposes such a valuable API to other customers or consumers for free to build really cool applications. And the applications that we're interested in today are payment applications, because a number of people think that the current payment systems are really in bad shape and outdated and overdue to be fixed, and OAuth can help us. So the motivation, and at any time during this talk, raise your hand. The Q&A doesn't have to be at the end of the talk, and I'll be glad to multiplex to questions at any time in the talk, so do not hesitate. Okay, so the motivation is there's this chapter written by Ed Bellis in the book Beautiful Security. It's called Beautiful Trade, Rethinking Ecommerce. And his idea was the current payment systems on the web are just ridiculous, because they're using credit cards. And what is credit card information? Well, it's a shared secret that's being shared during the lifetime of a card to thousands of merchants and other gateways and everything, and the weakest link is the one that's going to give away your data, and it's a terrible design. We know shared secrets across hundreds, thousands of parties is just asking for trouble. And the other problem is that the people who are tasked to protect it, well, they're not really the ones in control of doing that. And for instance, the consumer herself, it has no responsibility, because there's no risk. There's they're covered everything beyond $50 or whatever. So they have no incentive to protect it, and then similarly with the other parties in the transactions. So it's a fundamentally flawed system, which we can correct. There's a number of other problems with the payment system, obviously, but I won't go into those. I think that just by seeing how we can fix this shared secret problem, that we can fix those other problems as well. So one of the interesting payment APIs that have recently supported OAuth is Dwolla. They do $1 million of transactions a day, which is just amazing. And my understanding is a lot of those are from Bitcoin transactions, people cashing out their Bitcoins and stuff. But the API is really cool, and so when there's an application that's requesting permissions on your behalf to talk to Dwolla to make a payment, maybe they're wanting to credit you with money for Bitcoins. Well, what happens is that they redirect you, like in our lanyard case, to the Dwolla is the API provider in this case, and Dwolla lists a number of scopes, and so you can see the last one, the send money scope. That's kind of the important one. In that case, they'd be sending money out of your account, so maybe they want to withdraw money from you for some reason. Maybe it's a recurring payment or something. Other applications might not need all of these scopes. They might not need the send money scope. They may need just, if it's like an account aggregator like Yodlee or Mint, they may just ask for, account information and transaction details and balance, and they don't need to see your contacts and send money. So for that type of application, you'd only see like 3 scopes. And we'll look at scopes later in the talk. These are some links to some documentation if you're interested in checking out the Dwolla API. You can use the Ruby OAuth gem to talk to the Dwolla API, and it's pretty simple. The problem is that it makes assumptions, and we'll go back to this. There's 2 problems that could be fixed in the Dwolla API, I think. One of them is that the scopes are all or nothing. Either when the application asks you for the scopes, it's either click the allow button or don't allow. You can't selectively choose the scopes. So that's one problem that we can fix today. And another one is that it assumes there's only one asset class, which is the US dollar, and that's another limitation. So if we want to build a payment protocol, we need to address these 2 critical problems. We can't, this is not going to be a sufficient design for us. So there's some links for the Dwolla API if you want to check it out. So that brings us to the OpenTransact initiative, which was started by Pelle Brandgaard. He's the one who maintains the Ruby OAuth plugin, which lets you build servers and consumers of OAuth applications, and it's really good, and we'll use it today. I've linked to 2 mailing lists. The first one was the original Agile Banking mailing list that Pelle started, and the second one is the more recent OpenTransact mailing list, and that just focuses on the OpenTransact protocol, which is a really simple protocol, just bare bones, the minimum you need to make payments. So the concept, like I mentioned, we need to be able to support multiple asset classes. What are asset classes? They can be the dollar, frequent flyer miles, bitcoins, or hours, time exchanges, time banks. Anything that has value can be an asset class, and we need to be able to support handling. Our API needs to support transactions on multiple asset classes, not just one. So what do we use? We can use REST. The resource can be an asset class. Like here's the RESTful resource for the USD. Here's one for frequent flyer miles, for bitcoins, for hours. And OpenTransact is very simple. If you want to get your transactions, you just do get, and you get a list of the transactions for that person. If you want to make a payment, create a transaction, you do post. And the only things you really need are the destination ID of the account you want to make a payment to, and the amount, because it knows the unit, because that's represented in the URL that you're posting to. And then the destination ID, the to field, doesn't have to be email address. It can be an open ID. It can be a phone number. It can be a bank account ID. Whatever the OAuth provider or financial service provider supports. It's a very simple protocol, and you can easily create a consumer just using the OAuth gem. And it's very much like using net HTTP. You just do get and post, but you call get and post through an access token, and we'll see that in a bit. But there's also other levels of support that the OpenTransact Ruby gem provides, like get profile information of who's associated with the token that you're using, which is really important, or say get the scopes that are associated with this token. What capabilities is this token, does this have using the OAuth scopes? So there's a link to the OpenTransact Ruby gem. Here are some examples. One example is a SMS payment gateway. So if you've written an OpenTransact provider, you can easily hook it up to this Pay SMS application that Pele has written, and immediately start supporting cell phone payments with SMS. And then we're going to look today at Nov Mataki's OAuth.jp Karma, which was originally written to talk to OpenTransact server called Pico Money, but we'll see that it was easy for me to get it to talk to a server that I'd written called OS Currency. So here's Pay SMS, which is OpenTransact consumer, which uses the OAuth or OpenTransact Ruby gem. It will you can just say balance from your phone, or pay 10 units to some email address, and that's like a really useful application. And then here's OAuth.jp Karma, which lets you make payments and see other details about your remote account, and we'll do a demo. So the next thing I wanted to talk about is this really cool gem that Yehuda Katz wrote called Artifice. And what it allows you to do is make do specs for a server API, and in this case we're going to spec out the OpenTransact API, and what it does is it injects code into net HTTP so that instead of when you're writing your tests, instead of when the OAuth gem calls net HTTP, instead of it going out onto the network, it intercepts it and sends it to rack, so that your code is being tested, and it eliminates all the complexity, and I'll show you how that works in a sec. So there's a link to the Artifice gem. Makes designing OAuth APIs really convenient, and let's do it now with OS Currency. OS Currency is something I started writing in September 2008. It's derived from Insoshi, which was written by Michael Hartle, and it's an OpenTransact service provider. So here's a Cucumber test, or I guess examples for speccing out OpenTransact. And one question you might ask is, why use Cucumber, and why do you have these silly URLs in Cucumber? My customers don't want to mess with scope URLs. Well, the purpose of using Cucumber, the customer is someone who is writing an API, and so it's not your normal use of Cucumber where you're navigating a web page. You're talking directly to an API, so the API programmer is the customer, and that programmer she needs to know what scope URLs are. So in this case, we just want to list payments, and we have a number of scenarios. We want to do a successful list of payments. We want to see it error out when there's no asset specified or an unknown asset specified, a mismatched asset that doesn't match a token, and then finally one that supports multiple scopes. And when you ask for a request token, you specify the scopes in the body of the post, and the scopes are separated with a space. And so you can see here in this last step, we're testing that. So this is what Artifice looks like. Oh, okay. Let's see. Actually, we don't need to look at the red text. It's going to be the white stuff. So we looked out. So here, this is a step definition to test the requesting the transactions. So as you can see, there's a normal net HTTP type request going on through an access token, which is A. So you call a.get, and normally that would go out into the network. But if you wrap it around Artifice block, then Artifice will inject the code to intercept the request so that it sends it to your rack application instead. And then we can easily write these cucumber tests. So there's that's the one for listing the transactions. And then let's see, and there's the one for posting the transactions. You can see there's we pass it 3 options there, and the post body, amount, who we're paying, and then we send it to Artifice to the rack application. So that's enough of that. Oh, yeah. What happens is it rack processes it, and it goes to your routing as like normal. So so your server code gets the request through the routing and the controller and processes it like a normal like if a real client had talked to it. But yeah, Artifice is a gem that should get more exposure, because it truly, otherwise it'd be a real pain to make these Ruby gem, OAuth Ruby gem calls. So it's really convenient. Is it specifically for OAuth or just no? REST APIs in general, or oh. I'm sorry? Can you repeat his question to the mic? Oh, okay. The question was, is Artifice specifically for OAuth APIs? And it wasn't designed specifically for OAuth APIs. I just was looking for, how can I send requests to the rack application? And I did a search, and I found Artifice, and it was like, this is what I need. And so I guess the conclusion is, if you need to design an OAuth API, go get Artifice right away. Okay. All right, looks like I've got about 30 more minutes. Is that right? That can't be right. Oh, 15. Yeah, you get right around 15. Okay, I'm bad at math. Okay, so let's, since we got 15 minutes, I'll do a quick demo of OAuth.jp Karma, and then talk about future projects, and then do Q&A. So let's see, what am I doing? Oh, I'm totally needing some coffee. There we go. Okay, Nov Mataki, I guess, 2 months ago, wrote this sweet little OpenTransact consumer called OAuth.jpkarma. He used the picomoney.com server, which has a well-documented API using the OpenTransact spec to build it. And OAuth.jpkarma uses the OpenTransact gem. And so this is kind of a good example. And if we need to or we want to, we can go through the code and see how it's using the OpenTransact gem. But we can see that I was able to take this client that Nov wrote, and immediately I could start using it with OS currency. With the only changes I needed to make were for the scopes, because I had my own kind of scopes that aren't part of the OpenTransact spec. And that's generally the case, is that every OAuth provider kind of defines their own scopes. Twitter uses a different way to do scopes. Dwala has their own way of doing scopes. So it's unclear whether there'll be a common scope format for particular contexts. So OAuth.jpkarma wants to see if I will authorize an access token for it. So if you recall, with Dwala, it was an all or nothing thing. You either had to approve all of the scopes or cancel. Here, with OS currency, it allows you to select which scopes you want to approve. If you don't want to give it a payment authorization, well, then you can leave that out. And the way that I do that is with the access token, I have a relationship with a model called capability. So the access token has many capabilities. And so in this case, there would be 3 capabilities. And then you can invalidate each one of those capabilities individually instead of invalidating the access token, which would blow all the capabilities away. So I'll approve all of the capabilities there. And it says, hey, welcome, we've got your account now. And the OpenTransact consumer can call /OAuth/scopes to find out what scopes that you approved. So it's not like blind. It can actually find out which ones you approved and which ones you didn't, and then adjust to that. And then there's my profile that it picked up from the OS currency server using a method called about user. And so if I want to make a payment, I'll do that. And then transaction completed. And you can see my balance is really negative. And then there's also a call called wallet. And you can get a list of the asset classes the person has. And that was one of the scopes that I approved on the OS currency server. The last thing I wanted to mention was future projects. We recently started a conversation on the OpenTransact mailing list about how to support currency exchanges. This is particularly important for virtual currencies like Bitcoin and others, even Facebook credits, which is an interesting animal, and is a good way to make money, right? The Superman 3 kind of business plan where you take a little bit out of each transaction. So there's definitely a motivation for building currency exchanges. And then Federated Payments is, for instance, like the OS currency server is used by the Austin Time Exchange, the Bay Area Community Exchange in San Francisco. It's used in Athens, Greece. It's been translated into Greek, French, and Spanish. And so there's been some interest in, can I go to Athens and spend my Austin time exchange hours in Athens and vice versa? And how do you do a federated system to allow that? And it turns out with OAuth, it's really not that difficult. But that's kind of a future project that would need kind of collaboration among many people. So that's the end of the talk, and I welcome any questions or comments. Anyone? Yeah.
So, first of all, I'm still new to Rethinking, so I'm trying to figure out the ecosystem. But you mentioned a number of gems that were used, like particular the project you were working on. Can you kind of go back over some of those? Like, you're talking about, or I don't know if there were specifically gems, but like the Transact.
Yeah, OpenTransact gem.
Yeah,
okay.
How do they help you do what you're trying to do?
Okay. Yeah. Let's take a. Yeah. That's a great idea. That the question is I mentioned a few gems like the OAuth Ruby gem and the OpenTransact gem, and what do these gems actually provide us? And can we take a look at a code sample? So let's do that. This is code for the OAuth.jp karma, and it uses the OpenTransact gem to talk to, in our case, OS currency server. Can also talk to that picomoney.com server. And the OpenTransact gem, the main thing for this purpose is the transfer method. And so here's a model in OAuth.jp karma called transaction, which is used to manage transactions, lets you create transactions remotely on the server and that kind of thing. To create a transaction, it uses the OpenTransact gem. So, so in this case, what it does is there's a model called asset, and it calls transfer, and the transfer method looks very similar to what you need for OpenTransact creation of a transaction. You just need amount, who's it to, and instead of memo, he's called it description there. Oops. I just got this laptop for this presentation, so oops. Let's see where that is. So I haven't installed all my stuff here. Oh, let's do accounts maybe. Good morning. Yeah. There we go. Okay, I guess. Okay, what am I doing wrong? Let's do this. I'm totally spacing out. Oh, I'm digging myself a hole. Maybe. Oh, okay, there we go. Is this it? Yeah, there we go. Okay, so that's got to be there. No. Okay, so anyway, we'll start from this way, and I'll see if I can dig myself out of this hole. I've got 5 minutes to dig myself out. Okay, so the main thing here is with the OpenTransact gem is you need to create a consumer first, and the calls you're going to make are through this client thing. So the first thing you do, there's 2 steps in OAuth for the consumer. He needs to get a token and then a request token, exchange it for access token, and then use that access token. So so he's got this client thing where he can call get request token on it. And so if you go to client, that's here, and this is what's provided by the OpenTransact gem. So that's letting you get the request token, and this is just the first step for getting the token. It's not actually using the token. And so it uses this client thing. So that's the first thing you have to do is get that request token. And then there we go. Okay, now I'm starting to figure it out here. Okay, and then once you get the access token, let's see, where's the you exchange the request token for the access token. Once you have the access token, you can start making calls. And so the first thing that it does is it wants to call wallet. And so here it makes the calls to the access token. So just to find out what assets the guy has, he calls wallet, and let's take a look at access token. So access token is not using the OpenTransact gem. It's actually using the OAuth gem to get the access token. So the OpenTransact gem is just for 1 minute. OpenTransact gem is just for talking to the OpenTransact API, and then the OAuth gem is for doing little OAuth things like getting the access token and stuff like that. I didn't get all the way out of my hole there, but we got to see a little bit of it. Is there any other questions, quick questions? All right, well, thank you very much. I had a great time preparing the talk, and I hope it was useful.